Assalamualaikum and hi. Today we will to talk about applied maximum and minimum problem. Before that, let me introduce you to my group member. Firstly, I want to introduce myself. My name is Muhammad Khairil Rizwan bin Karol Anwar, and my group members Muhammad Adam bin Roslan, Muhammad Ashraf Aiman bin P. Rashidi, Muhammad Akim Mifzal bin Muhammad Aidil, and Muhammad Adam Shah bin Razmi Shah. To begin with, we need to learn about differentiation. Differentiation is the process of determining a function's rate of change at specific point. The derivative of a function is a brand new function that provides details about the original function, including its rate of change and local extrema. Applying a set of guidelines referred to as differentiation rules to the function results in the discovery of its derivative. The chain rule, quotient rule, product rule, and power rule are some examples of these rules.
Why use differentiation? Differentiation is a basic concept in calculus that is used to calculate the rate of change of a function with regard to its input. It is frequently used in physics, engineering, and economics to investigate how a system or function evolves over time. Differentiation can be used to discover a function's maximum and minimum points. It may also be used to compute the slope of a function at a certain position, which is useful in a variety of applications, such as determining the minimum amount of wire required to construct a block frame.
Okay, so now let me show you an example of a problem that is related to this topic. The diagram shows the block frame A, B, C, D, E, F, G, H, I, J with uniform cross section A, B, C, D, E constructed using wire with conditions. The length of AB is equal to AE, GH, and GF, which is 5x centimeter. The length of BC is equal to ED, FJ, and HI, which is 2x centimeter. The length of CD is equal to IJ, which is 8x centimeter. Lastly, the length of DJ is equal to CI, EF, BH, and AG, which is y centimeter. Now let me show you the question that can be generated from this diagram. Number 1, if the volume of the block is 985.6 centimeter cube, show that y is equal to 35.2 divided by x squared. Number 2, if the total length of wire required to build the block frame is LCM, show that L is equal to 44x plus 176 over x squared. And the last question is, find the minimum length of wire needed to build the block.
Now we'll begin the solution. For the first problem, we need to find the volume of the block and show that y is equal to 35.2 over x to the power of 2. To begin with, we need to find area of the cross-section, and that is area for ABCDE. And to find this area, we need to add both area BCDE and area ABE. This will result in a value of 28x to the power of 2. We'll substitute that into the volume formula, and after that we'll move 28x to the power of 2 to the other side, and this will give us y is equal to 35.2 over x to the power of 2. Now for the second question, it asks us to find the total length of wire required to build the block frame and show that L is equal to 44x plus 176 over x to the power of 2. Now, we need to come up with our own equation from the diagram itself. And we've come up with L is equal to 4BC plus 2CD plus 4AE plus 5DJ. We'll substitute in the value of each side, and this will give us L is equal to 44x plus 5y. Now the question asks us to find L in terms of x. So we'll substitute in the value of y from the previous question into this equation, and this will give us the exactly L is equal to 44x plus 176 over x to the power of 2. And finally, we have arrived into the final version, and it is to find the minimum length of wire needed to build the block. Now for us to find the minimum length, we need to differentiate the L equation first, and this will give us dl over dx is equal to 44 minus 352 over x to the power of 3. Now when we were talking about minimum length or the maximum length, we need to consider that L has a stationary value. Therefore, dl over dx is equal to 0. And after that, we'll substitute in the equation and find the value of x. And this will give us x is equal to 2. Now, when x is equal to 2, we'll substitute that into the length of wire equation, and this will give us the minimum length of wire is equal to 132 centimeter. But before that, we need to identify whether the x value itself will give us the minimum or the maximum value. Therefore, we need to differentiate it for the second time, and this will give us 1056 over x to the power of 4. And we'll substitute the value of x equal to 2 into that equation, and this will give us a value, and that is 66, which is over 0. Therefore, the value of L is minimum, and therefore, finally, the minimum length of wire needed are 132 centimeter.
In conclusion, differentiation is essential in many disciplines including mathematics, physics, engineering, economics, and technology. It enables us to analyze change rates, optimize system, and comprehend function behavior. Differentiation is an incredibly adaptable and powerful tool for comprehending, modeling, and optimizing real-world phenomena. I think that's all from us. Thank you and goodbye.